This is number 35 from section 7.1. It's dealing with the idea of angular velocity. If you think about regular velocity, you might talk about miles per hour, meters per second, centimeters per minute, something like that. You've always got a distance divided by a time, all right? Anytime you're talking about some kind of a rate, you're looking at how something changes in comparison to something other, to some other factor. So, you know, it might be dollars per candy bar or something like that, but you're always dividing some total by some other total. So you'll see here that the angular velocity formula is just theta, which remember represents an angle measure, divided by the time. And if you think about the units, this should make sense. You've got a tire that's spinning, for example, and we're basically saying, okay, how many radians does it spin through every minute? Okay, how many degrees does it spin through in an hour? Okay, that sort of thing, okay? So again, you might be able to visualize it a little bit better working with degrees instead of working with radians, but in the end, it really doesn't matter, okay? Now, this particular question is gonna be asking us this question is maybe a little bit misleading because they're asking us for the number of revolutions per second. I'm not sure that's actually an angular velocity. That would be more like radians per second, that sort of thing. But again, I think if you focus on the unit, that's really the key. Okay, so we want the number of revolutions per second, okay? And that's what we have to figure out. One of the challenges here is, this is telling us that every hour, the truck travels 55 miles, okay? First of all, we're dealing with a wheel diameter that's in inches. Okay, so a couple of things here. First of all, I need to figure out how many total revolutions the tire goes through. I really need to figure out how far would a tire go through in one revolution, okay? So if I have a tire sitting here and the diameter is 26 inches, if my tire rolls and this goes all the way around, notice one revolution of the tire should take it the distance of its circumference, okay? So one revolution is going to be equal to one circumference, okay? Remember, the circumference of a circle is 2 pi r, or pi times the diameter. And actually, in this case, we were given the diameter. So one revolution is going to be 26 pi inches, okay? We need to figure out, at 55 miles that you travel in an entire hour, how many total inches is that? I don't want it in miles, I want it in inches, okay? Because I need to figure out how many 26 pi's that tire spins through over the course of 1 hour, okay? So we need to convert that 55 miles. I'm just gonna focus on the miles here, not the miles per hour. I'm gonna convert that 55 miles to inches, okay? So remember, you can use ratios to do this. Hopefully you saw the other video where I looked at unit conversions, and again, called sometimes factor label method or dimensional analysis. I need to cancel miles, and that means I need to have my miles in the denominator of my fraction that I multiply by to convert. 1 mile, hopefully you know that 1 mile is 5,280 feet, okay? So what's gonna happen here is if I multiply by 5,280, miles cancel, and I'm left with feet, okay? So 55 times 5,280 tells me that there is a grand total of 290,400 feet in 55 miles, okay? That's how many feet this tire would travel, okay? But I want to know the number of feet that it travels. I want to know the number of inches it travels, because that's what the unit is that I have from the measurement for my tire. Okay, so we're going to take that 290,400 feet, okay, and I want to convert that to inches, okay? So I need to multiply this by something that would cancel feet and leave me with inches. So if I've got feet in the numerator, I need feet in the denominator of my fraction, okay? 1 foot is 12 inches, okay? So this tells me feet will cancel. I'll be left with just inches, okay? And it tells me I multiply by 12. And again, I know a lot of you probably knew that anyway, okay? And so what we end up getting there is 3,484,800 inches in 55 miles. Okay? Now, every spin of the tire is 26 pi inches. Okay? So I need to see how many 26 pi inches go into that 3 million inches. So I'm going to divide this total by 26 pi, okay? Make sure your 26 pi is in parentheses, okay? Because on your calculator, if you don't put it in parentheses, your calculator will divide by 26 and will multiply by pi, and you'll get something totally different. Or you could convert 26 pi to a decimal, I suppose, before you divide, okay? And that's going to tell me that I get a total of about 42,663 revolutions, okay? So again, we want the number of revolutions per second, okay? So I'm going to write this down here. We're going to have a total of about 42,663.319 revolutions. I did round slightly there, okay? Divided by the total number of seconds, okay? Well, it's going 55 miles in 1 hour, so I need to convert 1 hour to seconds. And again, a lot of you may know how many seconds there are in an hour, but I still want to just make the point here that we can make this conversion. Okay, so if I have 1 hour and I want to convert to seconds, first I can convert it to minutes. Okay, to cancel hours, I need hours on the bottom, and I would need minutes on the top. Okay, 1 hour is 60 minutes if I fill in my fraction. By the way, we can go ahead and do all these units at the same time. Then I want to cancel minutes, so I need to have minutes down here. Remember, I eventually want to know how many seconds there are in 1 hour, okay? So 1 minute is equal to 60 seconds, okay? So check out what's going to happen here. Hours will cancel hours, so I'll be multiplying by 60. Minutes will cancel minutes, I'll be multiplying by 60 again, and I'm going to be left with the unit of seconds. So it's 3,600 seconds in an hour, okay? Again, I know that's something most of you can do in your head, but I want to show how those units cancel. This will help you somewhere down the road. All right. So your tire is going to spin. It's going to make this many revolutions in 3,600 seconds. Okay, so we'll take that total I had before, divide by 3,600, and we're going to get a final result of about 11.85 revolutions per second. Okay, and again, you need to check the question. It was a little bit misleading because it said revolutions per second, okay? And the definition over here said that it was supposed to be radians per unit of time, okay? If they had asked you for this, you would basically want to come back. If it went through this many revolutions, every one of those revolutions would go through either 360 degrees, and you could multiply by 360, or if you were working in radians, each of those revolutions would be 2 pi radians, and you would multiply by 2 pi before dividing by 3,600, okay? So again, there's some different approaches that you can use there. If it was supposed to be in radians per second, again, you could really just take that answer and multiply by 2 pi, and it would be about 74.46. So again, I'm looking at the unit that the question asked, and it looks like the question wanted revolutions divided by seconds. So that's what I'm leaving my final unit in. But again, if it's radians per second, then you need to find out how many total radians, and you have to multiply each of those 42,000 revolutions by 2 pi, and then divide by 3,600, okay? But again, following the wording of the question, I would stick with that, all right? The next question basically asks you to do the same thing, just with a different set of numbers. And the final question, I think, tweaks the units a little bit, but it plays off of number 36. So I'm going to let you continue to work with those, but hopefully this gives you enough of an understanding that you can do something with those other two questions.